So we can give another y coordinate when x is -1, y is -0.5. Okay, so that's kind of seems like random information, but we're being asked, can we show that g of x has a horizontal tangent and whether it's a min or a max? Well, here I've just copied out the derivative of g that I got from above, so it's just the same derivative as I solved for here. And if I want to know if g has a horizontal tangent, I need to know it when this is equal to 0. Well, to be able to make this equal to 0, it's kind of hard because I don't know the expression for f prime and I don't know the expression for f. However, there is some parts I can factor to this. So I'm going to factor this. I'm going to factor out the common x. So I end up with f prime of x times x plus f of x. And by being able to factor out that x, making it equal to 0, I do know that there is a horizontal tangent at x equals 0. Now there may be more, because we don't know if this also may have zeros involved, but we can't really tell because we don't know exactly what these expressions are, and we don't know if we can factor this further. But we do know there is at least one horizontal tangent that results from that factor x. So I'm just going to put it into here. Here's my x equals 0. I know I have this is a slope of 0, so I know I have, actually I'm going to draw it like this. For x equals 0, g prime is 0, so I know the graph is looking like this. There's a horizontal tangent line at x equals 0. What I really want to know then is does this graph go like this to get a horizontal tangent, or does it go like this? So we don't know based on the information we're given so far. But we do have a derivative. We have this derivative, and all we really need to know is whether the slope is negative or positive on this side, and negative or positive on this side of the 0. Okay, well, I have some points that I can test because I've been given some information about the f function on the left side of 0, and I've been given some information about the f function on the right side of 0, which then allows me to make some implications about the left side and right side of the g function. So my g prime, I can just try to calculate g prime at -1. So negative values of x is going to be here. So -1, I want to know what's happening to g prime here. And if I plug it into this value, x is -1, I need f prime at -1 times -1 plus f of -1. Well, I have this information here because I can go to my graph of f prime at -1. That value looks like it's going to be -2. So I'm going to plug that in. So f prime at -1 is equal to -2, and that's from the graph above. Multiplied by -1 plus f of -1. Well, I've been given f of -1 right here. So this is my f of -1. So if I plug -1 into here, sorry, that's going to be -0.5. I can calculate the value of the slope at that point. And I don't really even need the value, I just need to know if it's positive or negative. And when I work this all out, it's a negative times -2, or sorry, +2, +1.5. This ends up being a negative slope, so I know if this is a negative slope, the g must be doing this. It must be going down to that region. If I then test what's happening at x equals 2, because I do have values of f of 2, I can determine whether it's going up or down. So I think I've calculated here. The slope of g of 2, at slope at x equals 2 of g, is going to be equal to positive 8. So if that's equal to positive 8, we can just say, generalize and say that g prime at 2 is equal to positive. There's a positive slope in here. That means the graph must be doing this. So looking at the shape of this graph, this definitely results in a minimum. So this is a bottom, it must be a minimum.